All right, for number one, which rule represents the above transformation? All right, so remember the apostrophe means this is the image and this is the pre-image. Okay, so it looks like the pre-image is moved 1, 2, 3, 4 to the right. So it's 4 right, and then after 4 right, it's 1, 2, 3 up. Okay, so remember X controls left and right. I'm sorry. Yeah, X controls left and right. What is it? 4, 1, 2. Oh, sorry. It's 3 right and 3 up. Okay, so 3 right, X plus 3. X controls left and right, and then 3 up, so X plus 3. So this is option D. Okay, number 4, how is the image of a figure that is dilated related to the pre-image? Remember, dilate is the only transformation that changes the size. Okay, so it changes the size. Congruent means exactly the same, right? It's same size, same shape. Okay, rotated means it's the same size, the same shape, it's just been turned. Okay, if the size has changed, that means it's similar. Okay, same angles but different size. Okay, and rotated. This also, it's been rotated. It's still also the same size. Okay, all right. Number 3. The outer figure is the image. The inner figure is the dilation. So the outer figure is the pre-image. The inner figure is the image. Okay, so let's go ahead and see. So it looks like the outer figure is the image. Oh, I'm sorry. The outer figure is the image of the inner figure after the dilation. So this is the image, and this is the pre-image. Okay, so it got bigger. Okay, so let's see by how much did it get bigger. Let's look at this point right here, right, and this point right here. So this point the x is 4, and this point here the x is 8. So 8 divided by 4 is 2. It got bigger, so it's not going to be 1/2. It's just going to be 2. Okay, so x is, so x times 2, y times 2. Notice the y, 4, and the y for that point is also 8. So the x and the y got bigger by 2. Okay. All right, so what is the scale factor in question 3? Oh, well, the scale factor if x and y are multiplied by 2, then the scale factor is 2. Okay. All right. Number 5. Which translation moves the point so that x point x so that the image is on the y-axis? Okay, so so which translation moves point x? Here's point x. So if you want it on the y-axis, okay, you want it, so here's point x, right? You want point x right there, okay? So it looks like it would have to move 4 to the right. Okay, so anything that says 4 to the right, x controls left and right. Okay, plus means going right, minus means going down. So the only one that has x plus 4 is option A. Right, x plus 4, that moves it 4 to the right, and then if it moves up 4, it's still going to be on the y-axis, right, for y plus 4. Number 6, XYZ is reflected across the y-axis. What is the endpoint y image? All right, so y is reflected across the y-axis. So here's y right now. So let's see, it's 2 away from the y-axis. It's 2 units away. So we have to move 2 units away on the other side. So there is where y image would be. Image y would be. Looks like that coordinate would be x is -2 and y is 3. Right, so option B. Number 7 says, which transformation takes point B to 2, 4? Alright, so let's pan out here so we can see both the question and the graph. Okay, so point B is moved to 2, 4. So here is point B right here. Okay, and it's moved to x is 2 and y is 4. It's moved there. Okay, so notice it's not a reflection. Notice also that the original point was 4, negative 2, and then it went to 2, 4, both being positive. You saw how it's a 90. You saw with with rotations, right? If it's a 90 degree, the x and the y flip. Okay, so this went from 4, 2, 4, negative 2 to 2, 4, positive. That's a 90 degree rotation. Okay, all right, so that's option C. Let's see, number 8. When you translate, rotate, or reflect, how does the new image compare to the pre-image? Okay, so the only thing, remember from number 2, the only thing that changes the size is the dilations. Okay, the size all stay the same, right? For these, the size always stays the same. Size stays same. Okay, so let's cross out C. If it's rotated, it only goes with a rotation, right? Translation, you don't rotate it, you just slide it. So it's not this one. All right, so which one of these means the exact same size, exact same shape, both size and shape? It's A. Right, same size, same shape. Okay, for congruent. Okay, number 9, in the figure above, which angle pair is a pair of corresponding angles? Corresponding meaning in the same position. Okay, let's look at 1 and 3. 1 and 3 are vertical angles, so it's not that one. Let's look at 7 and 4. 7 and 4 are not in the exact same position. 7 in its group is in the top right. 4 in its group is in the bottom right. Okay, so those are not corresponding angles. Let's look at 5 and 6. 5 and 6 are supplementary or adjacent. Okay, so it's not 5 and 6. Let's look at 4 and 8. 4 and 8 are corresponding. 4 is in the bottom right in its group. 8 is also in the bottom right in its group. Okay. All right, which one of the angle pairs is a vertical angle? Well, we said 1 and 3, right, are vertical angles. Directly across from each other, not sharing a border. Number 11, in the figure above, which angle pair is a pair of alternate interior angles? So, alternate different sides of the transversal, both in the interior. Okay, we already said 1 and 3 were vertical angles. That's not it. Let's take a look at 7 and 4. So it wants alternate and interior. So interior meaning interior of the parallel lines. 7 is in the exterior, right? It's outside the parallel lines. So 7 is not it. Alternate interior. Now 5 and 6. 5 and 6 are, adjacent angles, right? We would call those adjacent. Let's look at 4 and 6. 4 and 6, they're both in the interior and they're on different sides of this one transversal. Okay, so 4 and 6 is what you want here. The sum of the angles in a triangle is always 180 degrees. All right, two angles of a triangle measure 45 and 90. What is the third angle have to be? All right, so all the angles in a triangle have to equal to 180, right? They give us two angles here. So we're going to add 45 plus 90. 45 plus 90 is 135. Okay, so the last remaining angle has to be to find that last angle, we have to subtract that 135 from those two angles from 180. Okay, and if I do that, I get 45 degrees. Okay. All right, number 14. In the figure below, which of the following angles is congruent to angle 1? All right, so let's circle angle 1. All right, so let's circle the vertical angle to it. Vertical angles are congruent, so 1 and 3 are congruent. And then the corresponding angles to 1 and 3, corresponding to 1 is 5, corresponding to 3 is 7. So 1, 3, 5, and 7 are all congruent. Okay, so we look at our options here, 1, 3, 5, or 7. The only one that's on there is angle 3. Okay, so let's go ahead and look at the formulas here. So we have what is the volume of the cylinder below. Use the formula V equals pi r squared h. Okay, so we're going to find V equals pi 3.14. Okay, r squared, the radius is 2, so 2 squared. The height is 5. So I'm going to put that into the calculator here. Let's pull up the calculator. Move this over and pull up the calculator. Oh, that's not what I want. Okay. Alright, so for the calculator, once it comes up, if it doesn't, I will just use a handheld calculator. Looks like it's starting to come up. Okay, there it is. Alright, so 3.14, 3.14, 14, okay, times 2 squared, okay, and then times 5 is what we had, and it gives us 62.8, okay, and there it is right there, 62.8, okay. All right, number 6, the volume of the cone. Well, that's what we're looking for. That's the formula. So I'm going to type in here 1/3 times pi. Pi is 3.14. R squared again. So r squared. So I'm going to do 4 squared times the height, and the height is 8. Okay, so that's what I'm going to plug into the calculator. So let me go ahead and clear. Alright, so first thing is 1/3, so that's 1 divided by 3. 1 divided by 3. Okay, I'm going to scroll over. Alright, times 3.14. I can put it in parentheses like I have here, or just hit times. I'm going to go ahead and put it in parentheses this time. 3.14. Okay, times 4 squared. So I'm going to open up another parentheses. 4 squared. Close the parentheses. Times 8. Okay, so times 8. And that gives me 133.97, and I see that is option A. Okay, let's go ahead and do the next one. Alright, the volume of the sphere below, there's the formula for it, so I'm going to put in 4/3 times pi, so that's 3.14, times r to the 3rd. R this time is 4, so it's 4 to the 3rd. Okay, so I'm going to type that into the calculator. Again, for the 4/3 part, I'm going to do 4 divided by 3. Okay, scroll over to the right one. Times 3.14 this time. I'm just going to go ahead and hit times, just to show you the same thing. 3.14, okay. Times 4 to the 3rd, 4, and then I'm going to hit this AB button. So the exponent isn't just 2, right? I'm going to put in the exponent as 3. 267.94, 946, which is rounded, 267.95. Okay. Oh, I guess I didn't put. There it is, right there. Okay. All right. Number 18. The volume of a cone is this, 290 4.38. The radius is 7.5. Which of the following could be the height? Okay, so it gives us the volume, so we're going to go ahead and put in, it says the volume is already 294.38. So it's 294.38 equals to 1/3 times 3.14. It says the radius is 7.5. So I'll put in 7.5 squared, and it wants to know the height. Okay, so which one of these is going to be the height? All right, so I'm going to cover up this 294.38 here. I'm going to hit enter. Okay, here's what I want to do. I'm going to do 1/3, 1 divided by 3. Scroll over. I'm going to type in 3.14. Okay, so this time I'll go back to the parentheses. Times 7.5. Okay, so parentheses 7.5. Square it. Close my parentheses. All right, now what do I multiply what am I going to multiply with all those numbers to give me 294.38? Okay, so first thing I'm going to try is 4. So I'm going to do times 4. Let me see if it gives me what I want here. All right, times 4 gives me 235, not 294.8. Okay, so now I'm going to try 5 centimeters. So I'm going to delete that 4 and put in a 5. This time gives you 294.375. Rounded, that'd be 38, right? So this is what I want. I want that 5 for the height, and it'll give me that volume. Okay. All right, let's take a look at another volume one. This is a cylinder, and it says the volume equals pi r squared h. Careful here, they give you the diameter and not the radius. Okay, so the radius is going to be 3. Okay, it's just half the diameter. All right, so let's go ahead and plug in to find the volume. So pi, so I'm going to put in 3.14 r squared, so that's 3 squared. And then the height is 12. Okay, so let's plug that in. So 3.14 times 3 squared times 12. That gives me 339.12, and that's option C. Okay. All right. I think we're done with the calculator there. All right. Which equation has no solutions? All right. So for no solutions, this is a special case. Okay, where the x on both sides is going to be the same, but the constants are going to be different. Okay. So this one, look at option A. If I put in option A, if I distribute in, all right, so I have this x equals 5 times 3 is 15, 5 times 2 is 10. Hey, well, this gives me x equals 15 plus 10 is 25. That has a solution, right? X is 25. Let's go ahead and do option B. If I distribute this one in, I'll have this 5x equals 5 times x is 5x. 5 times -4 is a -20. Notice in this one, there's my equal sign. The x's are the same, right? But on the left side, there's nothing else. On the right side, there's this -20. Okay? This is the one that has no solution. The x term is the same. The constant is different. If I subtract the 5x on both sides, I'll have 0 equals -20, which isn't true, which is false. That means there's no solution. Okay, number 21. A line intersects the y-axis of a coordinate plane at 14. Okay, so if it intersects the y-axis at 14, touches the y-axis at 14, that means the line has a y-intercept of 14. Okay, so think y equals mx plus b. Okay, so the y-intercept is 14. It touches the y-axis at 14. Okay, so the only one here that doesn't have a y-intercept of 14 is option B. So we know it is not option B. All of these other lines, A, C, and D, touch the y-axis at 14. Okay. Now it also has to pass through the point 35, right? And this is your x and this is your y. Okay. So if we plug the x and y in, it needs to work in the equation. Okay, so let's plug it into A. So y is 5. So I plug in y is 5 equals negative 3. X is also 3 plus 14. Right? So I plugged in the x and the y into that equation. Alright, so let's go ahead and simplify it here. Negative 3 times 3 is negative 9 plus 14. Negative 9 plus 14 is 5. Hey, I get 5 equals 5. This is it. This is this equation here. This line has a y-intercept of 14, and 3 and 5 both work in it. Okay, 3, 5 as serving as the x and the y make that equation work. So that is on that line. Okay, number 22. Which statement about the diagram must be false? Okay, which one is false? Which one is not true? Okay, so the sum. Let's look at these two here. Let's look at each of these here individually. All right, so 1 and 3 have to, the sum, that means you add up 1 and 3 has to equal 30. Well, this 150 angle plus the 1 and the 3, yeah, they should add up to 180. So 1 and 3 should add to 30. This is true, right? 1 and 3 should add up to 30. The measure, so it says the measure of angle 3 has to be less than 30. Well, that's true also. If 1 and 3 have to be add to 30, then 3 has to be less than 30. It can't be 30 or bigger, right? Because then it doesn't leave any room for angle 1. Okay, so this also has to be true. The measure of angle 2 is 30. Well, the measure of angle 2 and this 150 angle, hey, that's a straight line, right? So those have to equal 180. So angle 2 also has to be 30. That's also true. The last one, D, says angle 1 is 30. Well, if angle 1 is 30, right, doesn't leave any room for 3, right? Because 3 and this 150 have to add up to 180. Okay, so 1 cannot be 30. If 1 is 30, that means it's 30, the angle 1, which is 30, and the 150, take up the entire 180, and then 3 has no room left for anything. Okay, there's no room left for nothing left for 3, right, for that triangle. Okay, so that's the false one. All right, number 23. What is the length of the diagonal D? Okay, so it looks like here we have a right angle with the 4 and the 2, so it's the bottom face. Okay, so we're going to use, it's a triangle, it's a right triangle, so we're going to use Pythagorean theorem. Okay, we're going to use a squared plus b squared equals c squared. All right, so 4 and 2, either one can be a or b. Those are interchangeable. So we have 4 squared plus 2 squared equals c squared. All right, we have a right triangle there. All right, so 4 squared is 16. 2 squared is 4. Okay, 16 plus 4 is 20. Okay, I'm going to take the square root. So c equals. All right, so let's go ahead and do here. Let's clear these other ones. Square root of 20. So square root of 20 is 4.47. 4.47, so about 4.5 units. Okay, number 24, find the distance between the 2 points, and it gives you a coordinate plane. All right, so -4, -2. So here's our x, here's our y. All right, so -4, -2, 1, 2, 3, 4, -4, -2, right there is -4, -2. Then you got 3, 2. X is a positive 3, y is a 2. All right, so we want this distance right here between those 2 points. All right, we can make a right triangle to help us. Okay, vertical line, horizontal line, there's my right angle. Okay, so let's go ahead and count the vertical length, 1, 2, 3, 4. Horizontal length, 1, 2, 3, 4, 5, 6, 7. Okay, so there's my A and B. Okay, so I'm going to use Pythagorean theorem again, right? A squared plus B squared equals C squared. Okay, so I have 7 squared plus 4 squared equals C squared. 7 squared, okay, 7 times 7 is 49. 4 squared, 4 times 4 is 16. Okay, now I have 49 plus 16. 49 plus 16 is 65 equals C squared. And I'm going to take the square root. Okay, square root is 65. That's a little bit bigger than the next lowest perfect square is 64, right? So square root of 65 should be a little bit bigger than 8. Okay, so there it is, 8.1. And if I did that in the calculator, it gave me the same thing. Square root of 65, 8.06. Okay. All right, so let me get rid of this calculator again. Number 25, find the equation that best fits the table. It looks like here for this table, first thing is the y as the x is increasing. The y is also increasing. The rate then, y is getting bigger, right, as x is getting bigger. The slope, the rate should be a positive, right? So you think about all these are in y, all your options are in y equals mx plus b form. Okay, so since the slope should be positive, look at B. The slope is negative. It's not option B. Look at D. The slope is negative. It's not option D. Okay. Let's go ahead and look for the slope. Okay, so the rate looks like the change in y is 1. The change in x is 2. Your m should be 1 over 2. Right, so 1 over 2. Is that right? I think there's something wrong with this problem. Okay, so 1 over 2, the y-intercept, because on this one, yeah, I think there is some, oh, no. Okay. The y is getting smaller. As the x is getting bigger, the y is getting smaller. So, A and C are not options, right? It's either D or B, right? All right, so let me say that again. Y is getting smaller as x is getting bigger, right? As you go down the table, y is getting smaller. So the slope should be a negative, so negative 1 over 2. Okay, so it's negative 1 over 2. So since it's a negative 1 over 2 slope, and your only options now are D and B, looks like it's got to be this one. Okay. If I find the y when x is 0, let's go ahead and follow this table here. X's are counting by 2's, right? So then x is 2, and then after that it'd be 0. Y's are counting by 1's, so getting bigger this time, so this would be 24 and this would be 25. Okay, so the y-intercept should be 25, so it should be option D. Okay. All right, number 26 looks like all the bases are the same. Okay, so we're going to have a 2 as our base being multiplied, so we're going to have to add the exponents. 2 plus 0 plus negative 5 is 2 plus 0 plus negative 5 is negative 3. That's our exponent. Okay, 2 to the negative 3. Negative exponent, I have to rewrite that as a fraction. 1 over 2 to the third power. And then 2 to the third power is 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So this is 1 over 8. That's option C. Number 27, 4 to the 5th divided by 4 to the 3rd. Same base. Okay, so I'm going to keep the base as 4. And for division, it goes with subtraction. 5 minus 3 is 2. Okay, 5 minus 3 is 2. That's our exponent. 4 squared, so 4 squared is 16. Number 28, x to the 3rd equals 27. That means x times x times x equals 27. Let's plug in first 9. 9 times 9 is already 81. 81 times another 9 is going to give you something much bigger than 27. Okay, so it's not A. Let's try option B, 3. Well, I put in 3 times 3 times 3, and 3 times 3 is 9. 9 times 3 is 27. Hey, the 3 works. x has to equal 3. Okay. All right, number 29. Which point on the number line is the best estimate for the square root of 7? So for the square root of 7, the next lowest perfect square is the square root of 4. The next highest is square root of 9. That's 2 and 3. Square root of 7 is between 2 and 3. Look at the only thing that's between 2 and 3 is point B. Number 30, which of the following does not represent a function? The only one that does not represent a function is option D. If I draw a line, vertical line for the vertical line test, it hits 2 points. It hits that one and that one. Right? Vertical line. Anywhere else for these other ones, if I draw a vertical line, it only hits 1 point. Vertical line here, it only hits 1 point. Vertical line here, anywhere I draw a vertical line, it hits only 1 point. Right? So D is not the function. Okay, I think this is the last page. Yes, okay. So for 31, choose the equation for the line below. It looks like the y-intercept right there. B is 2. Okay, it's a positive 2, so let's look at our options here. For y equals mx plus b. Okay, equals mx plus b. Looks like b is a negative 2 y-intercept, right? So is D, negative 2 y-intercept. Looks like the slope left to right is going down, so our options, two options are A and C, and they both have negative slopes. Okay, so we gotta get the rise over run here. All right, so I choose 2 points, get the rise over run. Looks like the rise is 1, the run is 2, so your m is negative, we said, 1 over 2. So it looks like it's option A, right? Negative 1 over 2. Which one of these is like to be irrational? Okay, so irrational, non-terminating, non-repeating. Okay, so, all right, so let's take a look at first option D. Okay, option D, it looks like this could be written as 6.072. Okay, so again, I'm going to write this down. Irrational, non-terminating, so it never ends. Okay, and non-repeating. Okay, this one's repeating, right? So it's not going to be irrational. Okay, this one could be written like this, 9.45. Okay, this one, it looks like it's cut off here, but I got a 42857. I think this one was 0.142857, and that's repeating. 142857, 142857. There's a 1, right? It looks like there's a repeat. There's a repeating section there. This one, there is nothing repeating here, right? There's no pattern. There's no repeating pattern. 194857, 3078652. Nothing's repeating. This one, right, is your non-terminating, non-repeating one, right? 194 ... right? This is your irrational number here. All right, next one, find the product. Okay, so for this, I would change this, so we're going to multiply, right? This product means times. So we're going to change this to scientific notation. Okay, so this is 3 times 10. It's a number less than 1, so it's going to be a negative exponent. And you would have to move the decimal. You have to put it behind the 3 spaces. Okay. All right, so let's go ahead and multiply. 5 times 3, or 3 times 5, right? This you times. And the exponents you add. So 3 times 5 is 15. Add the exponents, negative 3 plus 7. So it's 15. Negative 3 plus 7 is 4. Okay, but I don't see that here. We're going to rewrite this in scientific notation. Okay, the 15 is bigger than 10. So I'm going to put the decimal between the 1 and the 5. So 15 becomes a 1.5. It became smaller. The exponent has to get bigger. Okay, times 10 to the 5th. 1.5 times 10 to the 5th, that's option C. Okay, number 34. A is 8 times 10 to the third. B units long. B is 4 times 10 to the fifth units long. How many times longer is B than A? How many times longer is one thing than the other? We're going to divide. Okay, how many times bigger is 10 than 2? It's 5 bigger. How do you get 5 from 10 to you divide, right? 10 is 5 times bigger than 2. Okay, so we're going to have to divide these. All right, so B is bigger than A, right? B has the 5 exponent, A only has the 3, so we're going to do B divided by A. B is 4 times 10 to the fifth, divided by A, which is 8 times 10 to the third. 4 divided by 8, be careful, that's not 2. 4 eighths is 0.5. 4 divided by 1/2, or 0.5. Okay, and then you subtract. 5 minus 3 is 2. Alright, looks like the only option here that has anything with a 5 in it was A. But let's go ahead and rewrite it in standard notation. I have a positive exponent, so this 0.5, I'm going to move the decimal to the right 2 spaces, and I'll have a 50. Okay, B is 50 times bigger than A. Okay. Alright, number 35. Which graph from question 1 has a strong negative correlation? Alright, so from these, which has a strong negative correlation? Okay, so C has a positive correlation, not going to be C. D has a positive correlation, not going to be D. Okay. A and B have negative correlations. If it's a strong negative, then it makes more of a line. These points here in B, if I drew line of best fit, they make more of a line than these, right? These are more scattered around the line, right? This B makes more of a straight line. B is your strong negative. Okay, so for number 36, which table shows the relationship? I guess it's saying which statement shows the relationship between x and y. Okay, so y is 3 times the value of x. So let's check that one. Is y always 3 times the value of x? Okay, here's y is 3. 1 times 3 does give you 3. Okay, but look at the second one, 5. Does 2 times 3 give you 5? It does not. Okay, so y is 3 times the value of x. That's not true here. Value of x is 2. 2 times 3 is not 5. It's not A. Alright, next one says y is 2 more than x. Okay, so y is 2 more than x. Alright, so whatever y is, x is it's 2 more than x. Okay, so for the first one, let's say 1 plus 2. That does give you 3. Next one, 2 plus 2 does not give you 5. Okay, so it's not going to be B. Option C says y is 1 more than 2 times x. Okay, so it's 1 more than 2 times x. So let's go ahead and look at x. We're going to multiply it by 2. 1 times 2 is 2. 1 more. So plus 1. So this is 2 times 1 is 1, plus 1 is 3. Works. Okay, let's check this one. 2 times 2 plus 1. 2 times 2 is 4, plus 1. Let me write these down. Okay, so for this one, x is 1. 2 times 1, 1 more than it, plus 1 is 3. Okay, let's check x here. So 2 times 2 plus 1 is 5. Okay, now 2 times 3 plus 1, right? 2 times 3 plus 1 is 7, right? Gives you 7. Okay, so let's check the next one. 2 times 4, x is 4, plus 1 is 9. This works for all of them. Okay, y is always 1 more than 2 times whatever x is. Okay, all right. Last two. What is the percentage of urban credit card users? All right, so we know the total here is 100. Okay. What is the percentage of urban credit card users? Urban credit card users, there's 65 of those. Okay, 65 by 100, hey, that's 65%. Okay. Next one is a little bit different. It has, of the people that are in urban areas. Of the people that are in urban areas, there's 69 people in urban areas. That's our denominator. Okay. Of those people, what is the percentage of credit card users? Okay, so there's 65 of those 69 in urban areas. 65 of them use credit cards. Okay, so it's going to be a pretty high percentage here. Okay, so I think it's going to be B or C. Let's do 65 divided by 69. 65, clear. 65 divided by 69 is 94%. Okay, so 0.94. So that'd be option B.